Today in this class, I am going to discuss about the magnetic field at the center of a current carrying circular coil. Hope you will stay with me up to the end of this class. Well, here we consider a circular coil. Its radius is O, is its center, its radius is R, and we consider its current is I. Due to this current, a magnetic field will be created around the coil. Now we have to calculate the equation of magnetic field at the center of this coil. Now here we consider an infinitesimal length on the coil, and it is dl. According to Biot-Savart's law, the magnetic field due to dl at the center O will be, dB equals to mu naught I dl sine theta divided by 4 pi r square. Now, what is the angle in this case? When the current I reach at point D, its direction will be along the tangent. Okay, now this line implies the direction of current. So the angle between the distance r and the direction of current will be theta equals to 90 degree. So we can put the value theta as 90 degree and get mu naught I dl sine 90 degree divided by 4 pi r square. Next we can write mu naught I dl by 4 pi r square. Okay, this equation is, or the magnetic field is, due to the length dl. Now we want to get the magnetic field due to the total length of this coil. Then we have to integrate this equation. Then we get B equals to integration 0 to 2 pi r, because we know the circumference of this coil is 2 pi r. When we started from dl, then its initial value is 0, and when we complete the total circle, then its distance will be 2 pi r. That's why 2 pi r will be the upper limit and 0 will be the lower limit here. Next we can write mu naught I dl divided by 4 pi r square, or we can write mu naught I 4 pi r, because these quantities are constant, 0 2 pi r dl. After integration we get mu naught I 4 pi l, lower limit, upper limit. Now putting the lower limit and upper limit, we get B equals to, first we have to put the upper limit 2 pi r minus lower limit, and finally we get B equals to, here, mu naught I, here r square 4 pi r square into 2 pi r, and B is mu naught I divided by 2r. If the coil is n-turns coil, then the above equation will be B equals to n mu naught I by 2 pi 2r. Hope you have understood it. Now I will discuss about how we can calculate the magnetic field at the center of a circular arc. Okay, if it is not a complete circular coil, then how we can calculate magnetic field at the center? Suppose we consider a circular arc. Its center is O. Now the current flowing through the arc is I. Now due to this current, we have to calculate the magnetic field at the center. Now we consider an infinitesimal length of this arc. Suppose it is dl. Now the distance between the center O and the middle point of dl is r. When this current will reach at point dl, then its direction will be along the tangent. So this direction of current makes angle with r is theta, which is equals to 90 degree. Now according to Biot-Savart, the magnetic field at center O due to dl will be dB equals to mu naught I dl sine, here the angle is 90 degree, so sine 90 degree divided by 4 pi r square. Next we can write from it mu naught I dl 4 pi r square. Now for the whole length of the arc, the magnetic field at center will be B equals to, we have to integrate the above equation like mu naught I dl 4 pi r square. Next we know that S equals to r theta. According to this formula, here S is dl r and theta will be, if we connect the terminal end with the center, then we get the angle d theta. So it will be d theta. Now we can put the value dl here. Then we get mu naught I r d theta divided by 4 pi r square. Next we can write from it mu naught I divided by 4 pi r integration d theta. Next we can write mu naught I 4 pi r theta. So it is the equation of magnetic field at the center of a circular arc. Hope you have able to understand it.
The video and its content is subjected to copyright. Convention of this video elsewhere is a punishable offense. Any redistribution or reproduction of part or all of the contents in any form is prohibited. You may not issue or commercially exploit the content, nor you may transmit, duplicate, publicly display, or make derivatives of this video. The video is protected by intellectual property claims to stimulate and ensure originality. All rights reserved by Adamjing Cantonment College.